Good morning, students. Let's start our class today. Yesterday, we discussed the methods of substitution and transformation. As I said in the last class, that these two methods has to be used in complementary manner to solve integration problems. In fact, if you notice, that integration is there in class 12. Okay, but we are discussing now because it will help to solve several problems in physics, and to understand several problems in several theories in physics. And as long as the physics is concerned, what I have noticed is that the maximum thing is actually confined within the method of substitution and transformation. The other method that also you should learn, but today and the next class, what we will be doing, we'll be doing some practice on leveraging method of transformation and substitution. And I hope you got the question paper as available in the online test platform at KonarClasses.com. And I hope many of you actually solved the DPPs, what I gave yesterday. Now, from those DPPs, if you have any doubt, please do let me know. First, we will discuss those. After that, I will give you some problems and we'll solve together.
Sir, I have one doubt.
Yes, please. Tell me which DPP, which question.
Should I tell you the question or the...
Yeah, so it is better. If you tell me the question. Let me open that, DPP. Okay. Just a minute. Just give me a minute, please. So let me open the DPP.
Set 2, question 8.
Set 2, question 8, right? So let me open. Let me show to every one of you. So I hope you are able to view a new paper right now.
Yes.
That new window you are able to view, right?
Yeah.
So set 2.
Yes.
Now if I go to set 2, and which one?
Question 8.
Question 8.
Yeah.
So sec x into sec x plus tan x, right?
Yes.
Sure, we'll do it. So anyone has any idea how to do this one?
Sir, I got stuck where we had to integrate sec x tan x. That part I didn't understand how.
Okay, so now flip through your
yeah, that's sec x. Integration of tan x, sec x is sec x.
I'm sorry.
Is the integration of tan x sec x is sec x only?
Yes, exactly. What is the differentiation of sec x, Mohor?
The differentiation.
ddx of sec x.
That is sec x tan x. Yeah.
So then integration of sec x tan x?
Oh, that way sec x. Okay.
Antiderivative, right?
Yes. Yes. Okay.
So
I
this
thought.
question,
Okay.
so it is sec square x, integration sec square x plus integration sec x tan x, correct or not?
Yes.
Got it now or not?
Yes, sir. I got it.
Okay, all right. Any question? Any other question, dear students? Okay, great. So now,
for me, I didn't do the entire of set 3 because I had many doubts in that, like how to solve those problems.
Okay, okay. We will discuss. Let's everyone complete set 3, then we will discuss. Okay.
Okay.
So today, what we'll do? Today we will practice. Some problems leveraging both transformation and substitution. Correct, no?
Yeah.
So please confirm that you are able to view my digital screen. Correct?
Yes.
Okay. All right. Okay, the first question, what I'm going to give is something like this. You'll be able to get your question in few seconds in the screen. I hope the question is visible to you, dear students. It will be visible, sorry. It will be visible in another few seconds. In fact, I can do one thing. Till it is visible, you can have a look into it. You will view it now. No?
Yes.
Please note it down and start solving it. I'll give exactly 1 minute. Within that, you need to think. So here the question, you need to apply the concept of trigonometry because, if I give very long amount of time, then it will not able to solve many problems within the stipulated time, right?
Yes.
So here the question is, if you look into it, that integration, sorry, just a minute. Any idea by anyone?
So 1 second.
Yep, sure.
Sir, my idea is to take the reciprocals, like sine square becomes cosec square x and then sec square x into dx.
Hmm.
But then to integrate like u into v, will it
Correct.
follow the same rule for differentiation or is there like
No,
a...
no, no, no. Absolutely different rule.
Sir, is it tan x minus cot x plus c?
Yes, that is absolutely correct answer. But before that, to answer your question, Devanshu, it is not the same rule like differentiation. So that there is a rule called biparts. So that actually address a part of that. When there are two functions that are actually, you know, uh, multiplied together and how to integrate. But here it is. We cannot use that rule here.
Okay.
Anything you know from the others? Sagnik, Gurman,
So I got
Yes, sir, I got it.
you got it. So the way it has been done. So as numerator is nothing is there, we write it is sine square x plus cos square x. Disha, Shrigita, did you get it?
Yes, sir.
And this denominator is
Yes, sir.
cos square x dx, correct? So that is equal to Devanshu. If you look into it, so that is equal to sine square x by sine square x into cos square x. That means actual integration sec square x.
Yeah.
I'm sorry. Yeah, correct. Sec square x plus integration cos square x by sine square x into cos square x, that is equal to integration cosec square x dx. Correct or not?
Yeah. Okay. Then six
Then
square x
you
tan x
know what it is.
square x
Integration
is...
of sec square x is what? Tan x. Correct or not? Clear or not clear?
Yes, sir.
And integration of cosec square x is minus cot x. Correct? Plus C. Okay, good. Let's proceed to the next question. I hope you got the question.
Yes.
What happened? Got it?
Sir, after one step, I'm not getting it.
Yeah. So this question, if you are not able to do it, is perfectly fine at this moment of time, because integration needs lots of practice, and you have not done that much of practice, and that is quite obvious because we just started learning. See how we are going to do it. Anyone is able to do it, by the way. So what we can do is that we can write is that e to the power x cos x
Yeah.
minus e to the power x sin x
Yes.
dx. Correct, na?
Yeah.
So the point is that always remember one thing. We will learn one topic, and and then we will see that how we can do it very easily. Always remember one thing, that let's take a function called e power x cos x. Okay. Suppose we have a function e power x cos x. Correct, na?
Yeah.
Now let's differentiate this function. Can all of you please differentiate with me? What is dy dx? So it will be e power x cos x is what? Minus sin x, na?
Sin x.
And
Cos
then cos x into
ex, e to the power.
e power x.
Yeah.
So what we get? We get dy dx means, in this context, let me write ddx of y is equal to e power x of cos x minus sin x.
Yeah.
Correct, na?
Yeah.
So that means what? From the rule of antiderivative, we can say integration of e power x into cos x minus sin x dx is equal to y. Correct or not?
Yeah. Yes.
And what is that y here? In fact, I can write it is y plus c. Correct or not?
Yeah.
And what is y? Y is e power x cos x
Minus
plus c.
e.
So then you can directly write this is equal to e power x into cos x plus c, isn't it, dear students?
Yes.
Now the point is that you can say, sir, you are experienced and you are doing this, so how I can do this thing? So I'm going to give you a there is a purpose why I gave this question. So I'm going to, tell you one particular technique with which you can always find the differentiation very easily. What is that? If you find any integration, dear students, very important, e power x, here it is fx minus f dash x. Sorry, fx plus f dash x. Got it, no? Hello?
Yes, yes, yes.
Dx. That means if you find it is e power x into fx plus f dash x. That means if you see e power x in context to our question, cos x and plus minus sin x, because differentiation of cos x is minus sin x, na?
Yes, yes.
If you come across of this kind of situation, you can always write that integration is equal to e power x fx plus c. That's what we have done it here, e power x cos x plus c. How it
Yes.
is coming, I will explain you during integration by parts later.
Okay.
Okay, how it is happening? You can ask that, sir, prove me that why it is how it is happening like this. That we will discuss during that integration by parts. But remember this technique. Okay, if you get e power x one function plus derivative of this function. Let's take another example in a let me use a different. Suppose we get something like this, e power x into log x, not log x. Let me give something different. X square plus 2x
Yeah.
dx. We see that x square differentiation is 2x, na?
Yes, yes.
So we can write simply it is e power x into x square plus c.
Yes.
That's as simple as that. Got it?
Okay, yes, got it.
Can you proceed to the next question, dear students?
Yes.
Yes.
Okay. So next question will be available to you in another few seconds. I hope the question is visible to you.
Yes.
Great.
So I'm getting 2x to the power 3 by 2 plus x cubed plus c.
Yeah. What do you get?
So I got 2x to the power 3 by 2 plus x cubed plus c.
Come again once more. I'm sorry.
2x to the power 3 by 2 plus
Hmm.
x cubed plus c.
Okay. I think one thing you may mistake. I hope
So even I got the same thing.
you got x to the
Even I
power
got, yeah.
3, right?
Yeah, x to the power 3, yeah.
X to the power 3, then
Like first is 2x to the power 3 by 2 plus x to the power 3 plus c.
Yeah.
Yes.
Okay. That is correct.
Oh.
That is correct. Correct one. Yep. Okay. I hope everyone got it right. This is quite straightforward a question, right?
Yes. Yes.
Okay. So let me go to the next one. To solve this problem, you need to apply the concept of trigonometric simplification. So this is question 4. Okay, please go ahead. Take a couple of minutes. I gave you the hints. You need to use trigonometric simplification. Got it? So I think I can give the idea.
So one second.
Okay, what concept you are using? That concept using is the most important part.
So
Rest will.
like cos A into cos B is equal to half cos A plus B plus cos A minus B.
Correct. Exactly. That is the right formula. Correct. Okay. So it is cos 7x plus 4x dx. 7x plus 4x, correct? Plus cos 7x minus 4x. And this formula we have learned during trigonometry, correct?
Yes.
And if you recall, the method of transformation, there it has been mentioned whenever you give a method of transformation of trigonometric functions, right? What we have learned that if we have this kind of function which is not directly integrable, that is cos 4x into cos 7x, which is not directly integrable, then our target should be to transform that function or express that function as a sum or difference of trigonometric functions, correct or not? That's what we have achieved here.
Yes.
So that is equal to 1 by 2 integration. Okay, in fact first bracket is sufficient. Integration cos of 11x dx plus integration cos of 3x dx. That is equal to 1 by 2. Now you know what is cos 11x? How you can find cos 11x? How to find cos 11x?
So cos 11x is equal to 1 by 11 sin 11x.
Correct. Because you can assume now here, the first step we did transformation. Okay. Now let's do the substitution. Let's take only this part, that cos 11x. Let's now just concentrate on cos 11x and how to do this thing. So integration of cos 11x. Gurman, you able to follow?
Yes, sir.
So let 11x is equal to t. This implies 11 dx is equal to dt. So this implies now cos 11x is cos t. In dx is what? dt by 11.
Yes.
So we know that we can take out the constant out of the integration. So 1 by 11 integration cos t dt. Now what is the integration of cos t? It is sin t.
Yes.
So it is sin t by 11 plus integrating constant, suppose c1. Now as I said in the last class that you need to revert back the value of t. So that is sin of 11x divided by 11 plus c1. Correct or not?
Yeah.
So that value you can write directly here. So what you can write is that sin of 11x divided by 11 plus, in the same manner, you will get sin of 3x divided by 3 plus c, integrating constant. Correct or not?
Yes. Yes.
Clear?
Yeah.
Okay, now let's proceed to the next question. I hope you got the fifth question.
Yes.
And that is why first we learn trigonometry, algebra, then we have started learning differentiation and integration. Because trigonometry has a very close association with all this. Let me quickly write down the marking the question, so it will be helpful to you later when I will be sending the class note. Yes, I'm done. Yeah, please go ahead.
So for the first one, is it tan x minus sec x?
Yes, even I got that.
Yes, correct you are. Both of you are correct. But only one point is that you need to mention that it is tan x plus sec x plus c.
Oh, okay, plus c.
Correct, no?
Yes.
Actually, sorry, I made a small mistake. It is tan x minus sec x plus c.
Yeah, it's tan x minus sec x.
So you got it? The others, did you get it? So I did it in this way. You can suggest me that whether it was the correct thing or not, means, or you have done anything any better way or not. So I'm multiplying both numerator and denominator by 1 minus sin x. Then denominator will be 1 plus sin x into 1 minus sin x. That means 1 minus sin square x. Correct or not? Clear? So this is equal to integration 1 minus sin x divided by cos square x dx. This implies integration sec square x dx minus integration sec x tan x dx. All of you got it?
Yes,
Now,
so then
we know that integration of sec square x is equal to nothing but tan x. Correct? And integration of sec x tan x is nothing but sec x. Tan x minus sec x plus c. Clear? Okay. Now let's do the next question. How you are doing the next one? Gurman, you do the second one.
No, sir, I didn't do it right. So I'm doing it.
Okay, okay. Disha, you got the second one?
Sir, is it sec x minus tan x plus c?
Perfect. This is absolutely a correct answer. Very well done. So those who are yet to complete this one, look into it. That what we can do is that we can write here it is 1 plus sin x and minus 1. In the numerator it was sin x, so to keep it, as we add 1, we subtracted 1. But you may ask that why you have done so. Okay. So now we can write this as 1 plus sin x by 1 plus sin x dx. Integration 1 plus sin x by 1 plus sin x dx. That is actually integration dx. Correct, no? Minus integration dx by 1 plus sin x. And we just solved what is dx by 1 plus sin x, that integration, right? It is there in the left hand side. So we can write this is x minus tan x plus sec x and only one integrating constant. As I said in the last class, you don't need to give multiple integrating constant. That is not required. So now what we are learning in all these questions, you see that it is all trigonometric functions, but we are just looking into it that how we can make it in the form of a function where we can easily integrate using the standard formula. If you look into the first one, that is integration dx by 1 plus sine x, what we did a transformation. That same function 1 by 1 plus sine x is written as sec square x minus sec x tan x. But why so? Because these are directly integrable.
Yes.
Fine. Now we are going to discuss, next question I'm going to give you now. And I hope you are able to view question number 6 in front of your screen.
Yes.
Yeah. Any one of you find that whatever the solution, what I'm doing is you're finding it difficult, never hesitate, ask me so that I can explain all this. What is the approach you are thinking?
So we expand it.
No, not at all. If you expand it, then you will completely lost.
So
Why?
I
Okay,
was
yeah,
taking t equals to 1 plus ln x.
correct. That is the right approach.
But then I don't understand how
Okay,
to.
okay, definitely it will help. It will help you to answer. But before that, let me, answer to Divyansu. Okay, you are expanding. Okay, you expand. But after that, what?
Yeah, after that, even I'm stuck.
Exactly. So that means, so that's why sometime, as you are getting matured, you need to think that 2 steps ahead. Okay, I'll expand. But after that, what I'm going to get it? Because ln x whole square by x, very difficult to integrate. And that is what it is, 2 step ahead of thinking. It is not a very, I'm not telling that you need to think a lot ahead, but just that I'm doing that, expansion, but what I'm going to achieve out of it. Now, rather, can I substitute? So then what I'll do? So as Mohor suggesting that let 1 plus ln x is equal to t. That's what the substitution you did, no?
Yeah.
And that was the perfect substitution. But I wonder why you didn't get the solution. So now let's differentiate. That implies ddx of 1 is 0 and ddx of ln x is what? 1 by x.
Oh,
1 by x dx equal to dt, correct?
yes.
So then what it is, then this is actually by means of this substitution, it comes t square into t square into dt, correct or not? Because 1 plus ln x equal to t, so 1 plus ln x whole square is equal to t square,
Yes.
and dx by x is nothing but dt.
Oh, okay.
So that is t cube by 3 plus c. Now we need to substitute back the value of t, that is 1 plus ln x whole cube divided by 3 plus c, isn't it, dear students?
Yes.
Sagnik, Gurman, Disha, Srijita, did you get it?
Yes, sir.
Yes.
Yes, sir.
Okay, so now let's proceed to the next question. Question number 7 in front of you. Not to mention that function is not directly integrable. Then you need to think of that how I can make a proper substitution or transformation, whatever you think, because these are the two primary methods we need to leverage. It should not take that much of time. Anyone able to do it?
So I'm getting minus cos of ln x plus c.
Fantastic. That is the correct one. Okay, the substitution here, dear student, is that ln x is equal to t. Why I was saying that it is easy, it should not take that much of time. Whenever you find ln x, we have done one problem, right? Previous one. Whenever you find ln x and something is there, 1 by x integration, just close your eyes and make the substitution ln x equal to t. Why? Because we know the differentiation of ln x is 1 by x. So dx by x is equal to dt, correct or not? All of you agree to me?
Yeah.
So then this integration becomes what? This integration becomes sine of t into dt. Correct or not? Now we know it is now coming to a, that is the proper substitution, and come to a position where you can directly integrable using the standard formula. So what is that integration of sine t dt? That is minus cos t plus c.
Yeah.
And we know the value of t. We need to substitute back. So minus of cos of ln x plus c. Goodman, Divanshu, and Disha, Srijita, all of you, means I'm not taking any names, so all of you got it, right?
Yes.
Yes, sir.
Okay, all right.
Yes,
So
sir.
next, yeah, good, thanks. Next question I'm going to give, you need to little think about this question. And it is also a method of you need to apply the concepts of substitution to solve that one. And the question will be available to you in another few seconds. I hope you got it.
Yes.
Apparently it looks like a big one, but it is not that big if you can apply the substitution properly. I hope all of you are thinking, and I appreciate your thought process. But one guideline I'd like to give you is that x plus 1 by x, as it is given tan inverse of x plus 1 by x, that x plus 1 by x, you need to make it in such a manner that it will help you to the rest of the part, which is the algebraic part. You see x square minus 1, that is the algebraic expression. And in the denominator x power 4 plus 3x square plus 1, that is also an algebraic expression. So your target should be whatever the inverse trigonometric functions expression is given, that is x plus 1 by x, how you can express those algebraic expression in terms of x plus 1 by x. So able to express that two expression x square minus 1 and x power 4 plus 3x square plus 1 in terms of x plus 1 by x? Not? Let me help you. So the first thing in that line, what we can do is that as in the denominator we get 1 x power 4. So to express this thing in terms of x square, what we need to do, we need to divide by x square. So let's divide x square minus 1 by x square dx divided by x power 4 plus 3x square plus 1 divided by x square into tan inverse of x plus 1 by x. That time tan inverse of x plus 1 by x I am just keeping as it is. Then what we are going to get? We are going to get integration in the numerator 1 minus 1 by x square dx. Correct or not? And in the denominator, what we are going to get? It is x square plus 3 plus 1 by x square. Correct or not?
Yes.
And as it is tan inverse of x plus 1 by x dx. Dx is already I have written. Now it looks like a correct step, not because the teacher I am doing, because there is justification. Why? You know, x plus 1 by x we can substitute to t. Then what will be differentiation? Differentiation of x is 1 and differentiation of 1 by x is minus 1 by x square. Correct, no?
Yes.
So that means 1 minus 1 by x square dx already is there in the numerator. So it looks like that substitution will work. But now what to do with that other part of the denominator, that is x square plus 3 plus 1 by x square. So here also our algebra knowledge is coming. 1 minus 1 by x square dx divided by x square plus 1 by x square. What you can write is that x plus 1 by x whole square. Correct or not? So then what will get? X plus 1 by x whole square plus 1, because 3 is there, na?
Plus 1. Yes.
I hope all of you are able to get it.
Yes.
Tan inverse of x plus 1 by x. Now what will be our substitution? Our substitution now will be x plus 1 by x equal to t.
Yeah.
Correct or not? So let x plus 1 by x is equal to t. Now what is the ddx of x? 1.
1.
Yes, 1 by x square dx is equal to dt. That implies this is equal to, after substitution we get dt divided by 1 plus t square into tan inverse of t.
Yeah.
Correct?
Yes.
But what it is? That also is not very directly integrable. Then what to do after that? Then you think about what is the differentiation of tan inverse x? What is the differentiation of tan inverse x?
Minus.
No, not minus. If you scratch your head, then it is not correct. That you need to remember, as I said earlier.
1 by x square plus
Correct.
1.
ddx of tan inverse x is equal to 1 by 1 plus x square. That you need to say very fluently. And you can only say very fluently if you memorize well. So let's make another substitution. What is the substitution? So here make the substitution. Let tan inverse of t is equal to u. So this implies dt by 1 plus t square is equal to du. Correct or not?
Yes.
So this is equal to integration dt by 1 by t square is equal to du. Du by tan inverse du. And we know what is integration of du by u. Who can say?
So how does that become du by 1?
Okay. dt by 1 plus t square is equal to du, na?
Yeah. Okay. Okay.
Okay. What is integration du by u? Who can say? Divansu? Open your formula page and tell me. You should have your formula page in front of you. What I said in the last class. Divansu?
Yes, sir. Yes.
Keep your all the previous notebooks handy.
Is it U plus C?
No. How come it is u plus c?
So sorry, ln U plus C.
It is ln of mod u plus c. Why I wrote mod? Because ln should always take a positive value. Ln can return negative value, but ln will always take positive value. So ln of mod u plus c. Now we need to revert back the value of u. So what is the value of u? It is equal to tan inverse of t
Yeah.
plus c. Now again you need to revert back the value of tan inverse of t. So ln of
Plus 1.
tan inverse of x plus 1 by x. Correct or not?
Yes.
Plus c. Why all this revert back is important? Because tu is our assumption, right?
Yes.
All these are our assumption. So hence it is important that we revert back all these values. So what is the result we get? The result of this given integration is ln of mod of tan inverse of x plus 1 by x plus c. Correct?
Yes.
Absolutely clear. Any question anyone is having, never hesitate to ask me before we proceed for the next question.
No.
Okay, so what I can do is that I can give you some questions now that you can solve, and we all will discuss tomorrow again. And before that, I want you to there are two tasks in your hand. Okay, you can solve 2 more DPPs as available in the online platform. Got it? And the assignments what I'm going to give you now. So these are the assignments you can solve, and we'll discuss during the class tomorrow. Okay.
Sir, again, I have FITG class actually. So can I
No, that
I'll try to do
that you
Sir,
need to
I'll-
manage. This cannot be excuse for many long days. Okay,
Yes, I'll
that
try
you need to
to.
manage. Okay, I
Yes.
need assignments to be done. How you are going to do that? You need to think. You need to manage your own time. Okay.
Okay, yes, I'll try.
That is important because every day I cannot entertain this thing because I also have my own methodology, right?
Yes, sir, I will.
That you need to respect.
Okay, yes, sir. Sure.
Yeah, thank you. So I'm going to give you some assignments, dear students. Okay, so dear students, so what I expect from you is that you complete these assignments what you see in front of your screen, and at least 2 DPPs before we start our class tomorrow. Okay. With this, I would like to conclude the class for today. If you have any specific question, please feel free to me.
Oh, sir.
All right. Thank you.
Thank you, sir.